Okay, so in the last class, we have seen in the fifth unit, there are around 7 classes of materials. The first 3 classes of materials we have seen in the last class is the metallic glasses, shape memory alloys, and graphene. That we have seen in the last class. Today we are going to see the other 2 types of materials. Okay. In the next class we will see the other classes of materials. Okay. Um, there are actually not 7 classes, 8 classes of materials. I missed one. They have also given the polymers also as a separate section. So you need to study about the polymers also. Okay, so in this class, we are going to see about ceramics. Okay, so what are ceramics, how they are prepared, where they are going to be applied, especially in material, bio applications. Okay, and then for composites, we are going to see another class of materials called composites, and what are the advantages of these types of materials, composite materials. Okay. Uh, so I have given here some figures which are all made of ceramics. Okay, so first we will see ceramics and then we will move to the composites. Okay, so this is most of you would have seen this, which is a spark plug in engine. Okay, so this is made of highly insulating ceramic material here. Okay. And this is a ball bearing in a motor, which is made of ceramic material, aluminum ceramic material. And this is refractories, crucibles used in the refractories at a very high temperature to melt the metals to mold to prepare the materials. So this is made of zirconia, zirconia oxide. I think these are some of the ceramics materials which we are going to see in this class. Okay, so as I mentioned in the last class, few things you should know about these materials. Okay, so as I said before, I should know the definition for these materials, and then mostly the properties of these materials. Okay, the properties, and the applications. Okay, so let us move. Okay, so here I have given how the biomaterials for bio applications, the materials are classified. Okay, so biomaterials. This biomaterials we are going to see in the next class in detail. Okay, so the biomaterials can be classified as two for biomedical application. One is artificial origin, and another one is biological, natural origin. Okay, this natural origin you will be studying in your core material, in your biochemistry, molecular biology. In higher semester, you will study about these materials, or maybe you would have already studied about this one, collagen, elastin, chitin, and other natural bio materials. You will be studying. What we are going to concentrate now is on the artificial material. Okay? So we are going to concentrate on the ceramic materials and then composite in this class. Okay, so in this session, in the next session, we are going to study about the polymers and then sensors and then biomaterials. Okay. Especially this hydroxyapatite and then some bio polymers which are very useful, biostable and biodegradable polymer. Just as an example, we are going to study one polymer, PIMMA, I think. Okay, so we will see that in detail in the next session. So in this class, we are going to see about the ceramics and then the composites. Okay, so the how these ceramics and are classified, how they are classified, and then what are the applications. So this thing you should you should be knowing. Okay. So Yashoda, can you see this screen, biomaterial, ceramics?
Yes, sir.
Okay. So we are going to see some of the ceramics, how they are classified and where they are applied. Okay. In biomaterials, we are going to see this material, hydroxyapatite, which is one of the foremost biomaterial, which have been well studied biomaterials, well used biomaterials. That we will see it in the next class. So today we are going to see these three oxide materials. Okay. Ceramics, and then in composites we are going to see metallic matrix and organic matrix materials. Okay, composites. Okay, let's move to the next screen. I think. Okay. So in this screen, we are going to see what are ceramics, okay, and then how they are classified in general. Okay. This is a very old ceramic person. This you will be using. Most of you will would have been using this kind of utensils, ceramic utensils in your kitchen. And this is the scanning electron microscope of uh, ceramic material, as we have seen in the last semester, fifth unit. The ceramics polycrystals will have the grain boundaries. Okay? So these are all the grains. This is one grain, this is another grain, this is another grain, and this is the grain boundary. Okay, so the ceramics are made of polycrystalline material. Okay, so that is the definition. So ceramics may be inorganic, non-metallic solid material. Okay, it might be a metal or non-metal or a metal alloy, primarily held in ionic and covalent bonds. Okay, this is the definition for ceramics. It might be a polycrystalline material, or it can be a metal with a crystalline material with many boundaries and that. Okay, so why, how these ceramics are classified? Okay, so in general, the ceramics materials are classified as traditional ceramic materials and uh, structural ceramic material. Okay, so this is a very general classification. As per the application and as per how the materials are made, this is again classified into many different classes. So that we have been seeing here. Okay, so ceramics, they are also classified as glasses or glass ceramics, which are polycrystalline. Okay, and then they are also classified as clay products. Okay. Some clays are very useful, so they are also classified as clay products. We are going to see what are the uses, and then in refractories, how these ceramic materials are used in refractories. As I said, as I shown in the first slide, in refractories, you can use this alumina, zirconia, silica crucibles to produce high purity oxide materials and graphites, graphene, all these new class of materials. To prepare new class of materials, we need the refractories, which withheld a high temperature. Okay, so for that we will be using the ceramic. Okay, so again, there are some network problems, so I will try to fix that out. Okay, good. Okay, fine. So we will move to the next slide. So now we have seen what are ceramics, how they are classified. This is one of the most important application for ceramic material. Okay, sorry. Uh, the ceramic coatings, okay, ceramic coatings, which is used for surface engineering to protect the surface of your materials. So various materials have been used to protect the engines or to protect your material from chemical corrosion. Okay? So and it has a low friction. Okay, so these ceramics materials are chemically inert, abrasion resistant, low friction, and easy to clean. So most of the your engines or devices are coated with these ceramic coatings for these applications. Okay. Uh, for examples, the glasses, oxides, and carbides. Uh, so some of the main applications for ceramic materials, as I mentioned here, okay. So they are used in refractories. They are used in refractories. They are used in spark plugs. They are used in dielectric materials, in capacitors. They are used as sensors. We are going to study about sensors in detail in the next session. Okay. So we are going to. This is going to be used in magnetic recording media and the space shuttle. Okay, so the ceramic materials are used in a space shuttle. While uploading these PowerPoints, I will put a few more images, okay, so that it will be very clear. Okay, so the space shuttle makes use of around approximately 25,000 reusable, lightweight, highly porous ceramic tiles that protect aluminum frame. Okay, so from the heat generated during the re-entry of Earth's atmosphere. So this is one of the major problem. This is one of the major problem of the space shuttle. Okay, so you would have known about the Kalpana Chawla space shuttle accident. It happened because of this. There is a hairline crack in the uh, thermal insulator of that space shuttle. Okay, while re-entering into the Earth's atmosphere, that material broke, and then the whole space shuttle has broken. So still, there are quite a lot of researches going on the ceramic materials, especially the aluminum frame ceramic materials, where it can be used lightweight and then thermally insulating materials, okay, for space shuttle. So these are some of the applications where your ceramics materials can be used. Okay. So here I have given what are the functional applications, and where they are applied, and what are the ceramic materials which they have been used. Okay, for example, for electrical application in capacitors and dielectrics, these are the materials which are used. For example, barium titanate, strontium titanate, tantalum oxide, and then these composites. Okay, barium, magnesium, tantalum oxide, barium, zinc, tantalum oxide. So why these are changing their composition, you will study in detail. Okay, so by putting some tantalum and some magnesium, you are going to change some of the properties of this material. Okay, so that's how it will. For a particular device, you need a particular function, a particular property. To enhance that property, you are going to replace some of these materials. So that's why they are replacing these things. Okay. So conductive oxides, we have studied transparent conducting oxide. It is called the indium tin oxide. Okay. So for insulators, porcelain, this is one of the well-studied material. Okay, so solid oxide fuel cell. In fuel cell, you can use zirconia oxide, lanthanum manganate, and then for piezoelectric application, this is one of the very famous material, lead zirconium titanate, which is well known as PZT or PMN, lead magnesium niobate. Okay. So these are all used for electrical application, and then electro-optic modulators. When you study electronics, you are going to study. If you study electronics, you will be studying about this electro-optical modulators, in which lithium niobate and lead, lithium, zirconium titanate, which is all famous material. Yeah, you may study in detail in higher semester. Okay. In magnetic applications, it is used in recording media, especially chrome oxide, which is called as chrome cassettes, and then iron oxide, gamma iron oxide, Fe2O3, and then ferrofluids and your credit cards. This type of iron oxide. Fe3O4. In the last unit, in the fourth unit, you have studied about ferrites, right? A special class of antiferromagnetic materials which will be used for memory application. So this is one of that material. And so this will be having a spinel structure. So this can be written as FeO, Fe2O3. Okay, so that means A2 plus, B2 3 plus, and then O4. This is a spinel structure. Okay, so this is used as a ferrofluids, and nickel zinc ferrite, which is used as an isolator. Okay, and then it can be used as inductors and uh, highly powerful magnets. So for optical application, you can use these as a fiber optics. Okay, glasses. This everyone knows, silica oxide based glasses we have been using. Okay, in fiber optics, we are okay, in fiber optics, we are using doped silica oxides in lasers. We are using alumina oxide, and then for other applications. Okay, in for automotive applications, again we are using these are the ceramics. Okay, so for your case, biomedical. Okay, biomedical application. This material, as I said, hydroxyapatite. This is one of the well-studied material. So this we are going to, which is used for implants, okay, for bone implants and other tooth implants, and like those implants, we will be using hydroxyapatite. We will study in detail in the next class, okay, when we study about biomaterials. So this alumina oxide is used in uh, dentistry for dentistry application. Okay, so for ultrasound imaging application, for bioimaging. Okay, for example, if you want to scan ultrasound scanning, you would have here. For that, we are using this material called PZT material, which is a piezoelectric material. Okay. Construction, this is not for your application. Just as we know, cements, concrete, glass, and other sanitary wares, these are used for construction application for ceramics. Okay. For defense and armory also, we are using this boron carbide and lead zirconium titanate for piezoelectrics, for thermal imaging, and then night vision camera. For those applications, these materials, PZT, are used. And then for sensor application, this tin oxide ceramic is widely used. And then it is also used for nuclear application, uranium oxide. Okay, so these are the applications widely used in ceramics. Okay, so in the case of ceramics, you should know what are ceramics, the definition for ceramics, how they are classified in general, how they are classified as per the materials, whether they are oxides, whether they are chlorides, whether they are metals, metalloids, like that, how they are classified, and then what are the applications. Okay, so what you can do is you can concentrate on biomedical application and some of the electrical application. If they ask for application, you can concentrate on these two applications. Okay, biomed, because that will be very useful. Okay, biomedical applications, and then electrical application, and then the magnetic applications. Okay, so now we will move to the uh, next class of materials, which are called as composites. Okay, so in composites, so again you should know what are composites, how they are classified, and then what are the applications. Why the composites are better than the normal ceramics? Why we need the composites? These things you should be knowing. Okay, so here I have given an image of a normal chalk piece. Okay, where we will be using almost daily. Okay, so you all know this is made of calcium carbonate. Okay, calcium carbonate. Okay, calcium oxide, calcium based materials. Okay, so you know how these are all, these are all very brittle. It can break easily. Okay, uh, almost among the same material, these abalone shell are made of. These are made of this. Most of you would have seen seashells. Okay, seashells are made of again the same material, but the only difference is this is on the ceramic material, and this is made of. This is like a composite material. It is arranged in composites. Okay, so you would have seen how strong these seashells are. And so because this is like the same material, but it is made in the way of composite material. So one of the recently famous flight, okay, Boeing. Okay, so this is Boeing 787. Okay, almost 50% of this flight is made of composite materials, mostly carbon-based composite, carbon fiber-based materials. Why it is so? Because you can make the weight very light weighted flight. In that way you can save the fuel. Okay, so this is inside this flight, which is you can see it is mostly made of plastics and then composites to make the flight light weighted flight. Okay, so this is one of the applications which they are also looking out in the space missions also, to make a lightweight composites, so that to save the fuels. Okay, so what are composites? Okay, so composites is a combination of two or more materials showing better properties than the single one. Okay, so that's the definition for a composite. It is made of two or more than two materials, which is mixed together as a separate materials, so that they will have the advantageous properties of both these two materials. Okay, so one of the material is called as a reinforcing phase, and another one is called as a matrix phase. Okay, so in these composite materials, so there are. Okay, so in this class of composite materials, there are two types of materials. One is called as a reinforcing phase, and another one is matrix phase. So we are going to classify these things based on reinforcing phase or matrix phase. Okay, some of the examples are your plywood, naturally made the plywoods, which we are using regularly in your day-to-day life. Okay? It's not made of a single wood; it is made of layers and layers of different types of wood. This is a composite material. And then artificial composite materials like concrete, bricks, fiberglass, and other kinds of materials. Okay, so we are going to see how they are classified and where they are applied. Okay, so here I have given some of the examples for ceramic material. As I said before, this is your plywood. Okay, so you can see how many layers of wood it has been made of. That is why your plywood is very strong when you compare with the natural wood. Okay. This is the composite, which is the seashell, the cross section of the biomaterial, your biomaterial seashell. This is how the calcium carbonate layers are made. So this composites makes this material, this seashell so strong. Okay. This is fibrous composite. Carbon fibers are placed here, and this is called as your reinforcing phase, and this is your matrix phase. Okay, so this will have some kind of property, and your matrix phase will have some kind of property. When you mix these two materials, they will produce the advantageous properties of both this reinforcing phase and then this matrix phase. Okay. So let us see what is reinforcement phase and what is a matrix phase. Okay, so it is a strong materials combined with a matrix to produce your composites. Okay, it might be made of fibers and then filaments or glass, or sometimes the elements called carbon, boron, and other ceramics. Okay, your matrix is continuous material in your composite. Okay, which holds these reinforcement material. Okay, to make this as a high stiffness, high strength, and then low density materials. So your matrix may be metal, polymer, or ceramics. So your composites are classified based on these things. Okay. Okay. So how these composites are classified? Okay. So this is fiber reinforced plastics. That means your matrix is a plastic. Okay. This is a fiber reinforced metals. That means your matrix is a metal. Okay. So fiber reinforced ceramics, and then fiber reinforced glasses. So this is how different way your ceramic materials are classified. Okay. These composites are also classified mainly on fiber reinforcement, and then structural or particle reinforcement thing. Okay. So for exam point of view, what you should be knowing on these materials are you should know what are composite materials. Okay, what are composite materials, and then how they are classified, and how these fiber reinforced plastics and fiber reinforced metals are produced. Okay, and then some of the applications. Okay, so here again I have given how these materials are produced. Okay, so if you see here, this is these layers are arranged in a unidirectional way. So all are arranged in the same direction. So this will have uh, some applications. Okay. So if you see here in this diagram, this is not in a unidirectional way, not in the same direction, but they are rotated. Rotated. This one is like a 90-degree rotated, and this one is like a 45-degree rotated plate, and this one is again 45-degree rotated, but on the other side. Okay? So if you rotate your layers. Okay, so you will be having different properties. You would have seen in the last unit we have studied why diamond is so strong. Okay? This is because of two planes which will cross. Diamond is made of two FCC cells placed one over other. So if you cut a diamond, so you will go across two different planes. So that makes it very strong. So if you compare with these two materials, this will be much stronger because this goes on a different planes, different planes on different directions. So this will be much stronger than this material. Okay. So here I have given another example. This is your matrix. This is your fibers, mostly I think carbon fibers. Okay, arranged in between some glass matrix. So this is how your fibrous glasses are produced. Okay? So these are metals. So you put two metal bondings over other, and then if you put fibers in between and then a roll, you will get a composite.